Hello, I am Professor X. Today, we're going to solve a classic trigonometric problem involving secant and tangent functions. It's a great way to see how identities connect different functions. Ready to dive in? We are starting with the equation secant of x plus tangent of x equals a. We need to express cosine of x solely in terms of this constant. Pretty straightforward so far, right? Our goal is to manipulate the given expression using trigonometric identities to isolate cosine of x. Notice what happens when we use the fundamental identity relating secant and tangent. We use the identity secant squared x minus tangent squared x equals 1 by factoring this as a difference of squares. We get secant x minus tangent x times secant x plus tangent x equals 1. This part is important because it links our given term to its conjugate. Since we know secant x plus tangent x is a, we substitute it into our factored equation. This gives us secant x minus tangent x equals 1 divided by a. See the pattern. We now have two equations with the same two variables. By adding our original equation and our newly derived one, the tangent terms cancel out. This leaves us with 2 times secant x equals a plus 1 over a. Simplifying the right side, we get a squared plus 1 all over a. Got it so far? We divide by 2 to find that secant x equals a squared plus 1 divided by 2. Since cosine is just the reciprocal of secant, we flip the fraction. The final result for cosine of x is 2 times a divided by a squared plus 1. And this is why it works. If you have any doubts, use the doubt box below for more questions. Ask Professor X.